All right, previously we were able to take the equation of a circle with some different points and stuff and come up with the equation of a circle in particular. Let's say this green one here, its equation was x, let's see, minus and negative, so plus 3 squared plus y minus 2 squared is equal to 5 squared, 25, right? That's the equation of the circle, the green one. And let's say I wanted to put that into the calculator. Well, if I want to put something into the calculator, like if you call up your TI calculator, it usually has y1 is equal to. It's in y equals form. This is in function form. And you might remember from algebra, a function is every input has exactly one output. Is that true for a circle? Is a circle a function? Well, if it was a function, if I were to pick any input, let's say, for example, I pick negative 3. I plug negative 3 in for x here, negative 3. And I want to see what the y-coordinate is. Well, I can see from the graph, negative 3 has two different outputs. It has positive 7, and then it has negative 3. We can get that from the equation pretty easily. Like, for example, if I stick in negative 3 here, I'll do it in, let's do it in blue. Negative 3 plus 3, what the heck is that? There we go. Squared plus y minus 2 squared is equal to 25. Well, the negative 3 plus 3 would cancel out. That's just 0. And I'm left with y minus 2 squared is equal to 25. Okay, so to solve for y there, you could expand this thing out, but that'd be super dumb. Instead, you just take the square root of both sides. It's being squared, so let's unsquare it. We'll take the square root of both sides. So when you're solving an equation and you take the square root of both sides, you get two answers. You get a positive and a negative. You get a plus and a minus 5. So add the 2 over, you get 2 plus or minus 5. And you may remember something like this with the quadratic formula. It has like plus or minus, and you get two answers. One of those answers is 2 plus 5, which is 7, and the other one is 2 minus 5, which is a negative 3. Those are the two y-coordinates that we got right here, 7 and negative 3. It is definitely not a function. And remember that in terms of algebra, there's this thing called the vertical line test. If you were to draw a vertical line here, let me snatch it. I can snatch it, right? Yeah. And I try to draw a vertical line that passes through my graph, you can see that it hits more than one point. If it hits more than one point, it is not a function. Which means, all of that to explain to you that, yeah, we're not putting it into the graphing calculator as it sits. But we can trick it, and the way that we can trick it is by graphing two different functions instead. So let me kind of sketch a circle right here. And then if I were to just kind of divide this up into two pieces, like so, I get a top half. That part in itself is a function. And then I also have a bottom half down here. It by itself is a function. That's what I'm going to do. And I'll be able to trick my calculator into graphing a circle. Okay, you ready? Good. So let's take that same exact circle that we have right here. We have, just copy it down again, x plus 3 squared plus y minus 2 squared is equal to 25. Right, so what I'm going to do is I'm going to solve it for y. So I can put it in y equals form. Okay, so to solve it for y, I want to isolate this y term. To isolate it, I got to get rid of this thing. That doesn't mean you have to expand it out. No. Just treat this as one thing, one big term that we're going to subtract to the other side of the equation. It'll look like y minus 2 squared is equal to 25 minus x plus 3 squared. Okay, just very similar to what I did right up above here. Now I want to unsquare this. I want to try to get the y by itself, so I have to get rid of the square. And I'll get rid of the square by taking the square root of both sides. So square root on that side, square root on that side. On the left-hand side, the square root and the square should cancel out, and I will be left with y minus 2 is equal to, and then just like I did up here, I get two answers. I get two square roots. I get the positive one and I get the negative one. So it's important to put both of them, plus or minus the square root of 25 minus x plus 3 squared. And now don't go like cancel crazy. This square root and these squares do not cancel out. And the reason why is because we have this operation that is in between them, which must be performed first. Okay, and then the last step is this. I'm going to add this 2 over to the other side. So y is equal to 2 plus or minus the square root of 25 minus x plus 3 squared. And just like with the quadratic formula, you have two answers here. And those two answers are y is equal to 2 plus the square root of 25 minus x plus 3 squared. And the other one is y is equal to 2 minus the square root of 25 minus x plus 3 squared. So let's see how our calculator can handle that and what that actually looks like. Okay, so I call up my calculator. If you have your little TI calculator, if you have one of those handy or an emulator or something like that, you just go to y equals. This is my equivalent of that. It's saying f sub 1 of x. It's our first function. And I'm going to type in, I think it was 2, and I'm going to do the plus one first. So plus square root, and inside here was 25 minus, and then in parentheses, x, was it plus 3? I think it's, yeah, plus 3. And then I need to arrow out of this and then square it. And then let's hit enter. Boop. Let's maybe zoom in just a little bit there. Hey, look, what did we get? We got the top half of that circle. It's this top semicircle that's right there. Okay. And then let's do the same kind of thing just for the minus one. So it was 2 minus the square root of 25 minus, and then in parentheses, x plus 3. Arrow out of it and square it and hit enter, and boom, there's the bottom half. And that's identical to the graph that we just did, except for it's like totally technologically perfect, right? And so when I come back over here, when I do this, this is essentially, what colors did I, let's make sure I match this up. This is the bottom half of that circle, bottom semicircle. Right, and then I think I used blue on the other one. That one is the top semicircle. So a circle is not a function, it's actually two functions in disguise. All right, so that wraps up this first objective about being able to define and use, graph, whatever, the equation of a circle, which is basically based on the Pythagorean theorem in right triangles. X minus h squared plus y minus k squared is equal to the radius squared.